It's such a pleasure to be here today. And as Tony mentioned, the work that I'm going to tell you about is a relatively new line of research, at least in terms of us publishing. But we've been working on this idea for about 4 years. And in its most basic form, it's the idea of how our affective experience, emotion or stress, is transmitted to others around us, and how we can use online physiological responses to understand this affect contagion. And if you look in the animal kingdom, the idea that animals pick up on each other's behavior and responses is abundant. Whether it's fireflies who blink synchronously, if you separate fireflies and put them in a dark room, they'll sort of blink intermittently, and then within moments, they'll synchronize. Crickets chirp and frogs croak synchronously. And one of my favorite examples, the male fiddler crab, as part of their mating ritual, who go out on the beach and they'll synchronously, the males will wave their dominant claw back and forth, almost like a conductor with a baton, and then the female fiddler crabs approach the ones with the largest claw to mate with. But it's not just in our close relatives in the animal kingdom. We see synchronous responses in many varieties of human social groups, whether it's the synchronized menstrual cycles of women who live together, or this great example in Steve Sturgat's book called Sync of Eastern European audiences spontaneously clapping in unison. There's work showing that family units will have synchronized oxytocin levels. And of course, another fun example, the idea that as we age, our closest partner tends to mimic our facial expressions, and we might even begin to start looking like them as we age. So these questions that I'm going to talk about today are varied, and I put some of them up here. But the idea that how can synchrony be measured dynamically? What are the individual and dyadic features that potentiate synchrony, or what creates two people coming together and having these synchronous responses? How important is closeness or similarity? Do I have to know you well to have a synchronized physiological response? Am I more likely to pick up on your emotions if I know you well? What's the function? And are there benefits or drawbacks to synchrony? So I'll try to cover some of those questions today. But I'm going to start with one of my favorite examples of synchrony that was in a study almost 20 years ago in JPSP, where they took 25 Larry King interviews, and all of these interviews were with just Larry King and one other person. And they looked at the low-frequency nonverbal signal within this dyadic interview. And they asked two questions. The first question is, will the two voice frequencies converge on the same low frequency level? If it does, how long does it take to happen? And then the second question is, how is that convergence achieved? Do two voices at different frequencies sort of come together and sort of, I go up and you go down? Or does one person sort of drive the other person to speak at their frequency level? And what they found is that Larry King and the person he was interviewing do converge on the same sort of low frequency nonverbal signal of their voice, but status played a very important role in who was more willing or who accommodated and changed or modulated their voice to match their partner. So for an example, when Larry King was interviewing people who presumably were higher status than him, heads of state or royalty, there was a dominance effect where the higher status person was more likely to influence Larry King, and Larry King changed his voice to match theirs. But when he was interviewing somebody presumably lower status, in fact, the most remarkable example in the list was Spike Lee. Spike Lee accommodated and changed his voice to match Larry King's. So there's an interesting example of how we can become synchronized in an interaction with somebody we might not even know well pretty quickly, and it can be measured reliably and dynamically. Now, there are lots of examples of researchers approaching the question of how our behavior and our affective experiences are spread, in this case, within a social network. Socioepidemiologists Christakis and Fowler have many examples of behavior and affect spreading within social networks. Everything from obesity, so if I'm overweight, my friend's more likely to be overweight, and my friend's friend is more likely to be overweight. Or if I quit smoking, my friend's more likely to quit smoking, and so on. One of my favorite examples is smiling in Facebook photos. And I've always thought these graphs are a little bit like a Rorschach test or tea leaves. So what you're supposed to see is sort of the clumping of light colors, and that's signifying a specific behavior, and each node is a person, and they're connected by these red lines. And when you see a like color, in this case blue, that indicates smiling in a Facebook photo, and you see that then there'd be a clumping of colors. My friend's more likely to be smiling in their Facebook photo, and my friend's friend, and so on. That's a socioepidemiologist perspective. Social psychologists approach this same question in multiple ways. And I think if you've been following sort of my stream of thought, I've already used a couple different ways to say synchrony. And it's because it's a larger category for lots of things that social psychologists study, including social coordination, mimicry, and affect contagion. This is a picture of me and Tony from grad school. Tony's ironing, and we were talking about we're not that old. So social coordination, mimicry, and affect contagion are all the ideas that we're going to mimic the behavior of those around us. Really fun, great work on mimicry. The problem being that you have to wait for a behavior to occur. You have to be sure that the fidelity of that behavior means what you think it means. And also, sometimes these behaviors aren't tied to any kind of mental state. So what's a social psychologist to do? Well, if you're a social psychophysiologist, like I am, you look for measures that you can measure from the body continuously, dynamically, that can change in a predictable amount of time based on a mental state. So if I experience stress, something broad like that, I know that there's a certain amount of time before I can detect that change in a physiological system. And you want to pick physiological signals that have some meaning in terms of their mental state and can be reliably measured. So I'm going to show you a couple different measures that we use to look at this idea of physiological synchrony. Now, I also don't want to stand up here and pretend that there hasn't been decades of work on physiological synchrony. And in fact, the oldest one that I could find dates back to the 1950s, where they looked at physiological synchrony within therapist-patient dyads. So just looking at something as simple as heart rate. If your therapist had a heart rate, the patient was more likely to have a high heart rate, and then this changed over time. The implication being that the greater the synchrony in those therapist-client interactions, presumably the better the treatment, though the data were never quite that clean. Probably the most seminal work is by Bob Levinson and John Gottman with their married couples. The extent to which couples were well synchronized versus not, they argued could predict divorce. And then some really nice work about a decade ago by James Gross and Emily Butler, showing that even for females who didn't know each other, if one female was more stressed and she was actually suppressing her emotions, when she came and interacted with another female participant, that female participant who she was interacting with had elevated blood pressure, or the idea that the suppression of an emotional state from one person can influence the physiology of somebody they're interacting with. So when we approach synchrony, there's a couple different ways to think about synchrony at a physiological level. And I'm going to talk about both of these approaches throughout my talk. There's the top one, the physiological covariation. This is concurrent physiology. This is measuring two people's physiological responses at the same time and watching how they rise and fall in a similar manner. We call that covariation. The idea here is that any sort of strong covariation is picking up on a shared mental state or shared reality. The bottom is physiological linkage, or a time lag model, the extent to which my physiology at time 1 can predict your physiology at time 1+1. And we can do lag models to ask the question of how one person's physiological responses can change and influence their partners. And then you can reverse the model. So they answer different questions. And again, I'll be returning to those two different ideas later. So what does one measure if they want to measure physiological covariation or synchrony? There are two branches of the autonomic nervous system. And what you want to do as you're choosing these measures, and we think carefully about what measures we choose, is you want to pick a measure that provides a pure window into one particular branch, for example, of the autonomic nervous system. So to measure something like sympathetic nervous system, we use a measure called pre-ejection period. The picture on the right has a model where he's wearing impedance cardiography. In impedance cardiography, it's a band electrode system. 4 milliamps of electricity are sent to the two outer tapes. The inner tapes pick up the resistance to that current, and then the first derivative of that, or the change in basal impedance, or the change in the blood flow in your thoracic cavity over the change in time, gives us the blue line. It's just a really complicated way of saying we could look at how blood is processed through your heart. And so, for example, we take an ECG wave, the standard one you've seen lots of times probably, and we superimpose this impedance waveform, and this distance between the left ventricle contracting that forces the aortic valve open tells us a pure measure of sympathetic nervous system reactivity. So above and beyond heart rate, what's a pure measure of sympathetic responses? So it's a time-based measure. The shorter, the greater the contractile force, and the greater the sympathetic activation. Highly sensitive measure, not terribly specific though. Like lots of psychophysiology, I can't tell you exactly what somebody's feeling. I'm going to say broad things like arousal and intensity rather than happy or sad. But it does tell you something meaningful about the general arousal state of a person. We also look at the physiological synchrony using the other branch of the autonomic nervous system, the parasympathetic nervous system. So if the sympathetic nervous system was fight-flight, your parasympathetic system crudely is rest and digest. And here we're looking at the high-frequency heart rate variability. So just to give you an illustration, I could look at the time between each of these R spikes, and your heart is not like a metronome. It doesn't beat exactly at the same pace. It varies, and that's what heart rate variability is. Presumably, that variability is due to the cardiac vagal nerve coming down and regulating the heart. The greater the variability, the more the vagus nerve is working, and then presumably, the more the parasympathetic system is activated. When people are feeling, again, it's a sensitive measure, not terribly specific. In general, you could see heart rate variability decreases when people are attending to something, attention, mental effort, but also negative affect. So lots of mental states will drive down heart rate variability. And lots of mental states can increase it too. Possibly things like social engagement, but also calm states will increase your heart rate variability. So we'll be looking at responses from both the sympathetic and then to a lesser extent, the parasympathetic. Tessa West and I have been working on these ideas for a couple years now, and I wouldn't say yet we have a theory, but we do have a general working model. And this is a lot to sort of bring in, but I just want to maybe direct your attention to our left side of the panel, which is what are the factors that contribute to this affect contagion, this physiological synchrony? And there's sort of the idea that there are these low-level processes, like what I can see, hear, touch, and smell. So I can pick up on your emotional experience. Maybe I don't even have to know you or even imagine what you're thinking, but I could just see maybe, a terrified expression on your face or hear you scream. I don't have to think too deeply about that, and I might be able to pick up on that affective experience. There's also these higher level processes, things like mentalizing, me try to imagine what you're thinking. how perceptive I am or motivated I am to imagine what you're thinking or feeling, and also how readable are you. So these low-level and high-level processes influence the likelihood that we are to pick up on each other's emotions. And then the far right panel is what we think it might be useful for, things like mutual trust, cooperative performance, and accuracy. And I'll show you a little bit of data supportive of that. So I'm going to talk about 3 different sort of series of studies, all looking at physiological synchrony, starting with sort of the lowest hanging fruit for us, which was the closest dyadic pair we could think of, which is a mother and a baby. We're going to look at some stress contagion studies. Then we'll move to the question, maybe a harder question. If I can pick up on the affective experience of my child or my mother, can I pick up on affective experience for somebody who I just met? Sort of what are the factors that contribute to me being able to pick up on those affective experience and what the role of status is. And finally, I'll go back to my roots with interracial dyads and ask about physiological synchrony within dyads who either are the same race or different race. So let's start with the mother-baby stress studies. In this study, we brought in mothers and their 12 to 14-month-old babies. That age span was chosen because that's when social referencing is at the peak in terms of the developmental process. That's when babies are reliably using their parent and their caregiver as a reliable source of information. We brought in the mothers and their babies, and we randomly assigned the mothers to one of 3 conditions. So the mother and baby arrive, the baby goes into another room with a caregiver who came with them, often a grandmother, sometimes a babysitter, sometimes the father, and the baby gets to play and have a lovely time. The mother instead goes into a room, and we apply physiological sensors on her, and then she finds out that she has to give a speech and do a math task and answer questions to 2 evaluators. Standard Trier social stress task, a reliable way to activate the HPA and the sympathetic nervous system. And what we manipulated is whether these evaluators provided negative nonverbal feedback during the speech, so crossing their arms, activating their brow muscles, kind of shaking their head, being rather negative, or the social evaluation as the mother starts talking, they nod, they lean forward. And that still is socially evaluative, but it's much more pleasant, so more of a positive stress experience. We also had a 3rd condition that's a no stress control task. So the mothers are in the room, they do all the same tasks, like they still have to give a speech and do math and answer questions, but nobody's in the room and everything is cued from index cards. So now what we've created are conditions that hopefully are differentiating the mother's affective experience. In negative feedback, we expect her to be threatened, probably angry, activation of HPA and sympathetic. The positive stress condition, again, arousal should be high, but probably the valence not so negative. And the no stress, neither arousing nor negative or positive valence. We then reunite right after the speech. The evaluators leave the room, and the baby is brought back in and placed on the mother's lap. Now we can measure the baby's responses. Of course, the baby knows nothing of what just happened to their mother. They're also not at an age where the mother could say much to the baby about what just happened to her. And we can measure the mother's physiological responses, their covariation, and then their behavior to the evaluators who come back in. So just to give you a little bit more concrete timeline, the mother arrives after a baseline, but before the mother knows what's going to happen, we bring in the infant for their baseline period. So now we know what the mother and the infant look like before any kind of manipulation of stress, take the baby back out, and then they run through the whole study here. The mother's alone in the room, there's a reunion, they get to rest together. All this part, the mother and baby are together. In these post-stress interviews, the evaluators who evaluated the mother come back in one at a time, and we code to what extent, so they interview the mother, and the baby's on the mother's lap, and we code the extent to which the baby is looking at the evaluator, maybe pulling away from the evaluator, and then the evaluator offers a toy to the baby. And again, we look at the avoidance or happiness of the baby to take that toy from the evaluator. So here are just some screenshots of our mothers with our baby. You could see here, this is one of the interviewers coming in a split screenshot. You could see here the evaluator's this way. You could see the baby looking right at the evaluator. So first, let's just consider, how did the mother respond? Well, not surprising, if you see on the far left, when the mothers rated how supportive the evaluators are, not surprisingly, the evaluators who give her positive feedback are seen as more supportive than those who gave her negative feedback. And you see a really nice differentiation in terms of her affective experience relative to baseline. So if you ask a mother who got negative feedback from evaluators, what's your emotional experience? Especially on the externalizing negative affect, this is hostility, anger, and irritation, getting negative feedback is much worse than getting positive feedback, and very little change in the control condition. Similarly, HPA is differentiated, in this case, the end product of cortisol. We've published lots of papers looking at this paradigm where we give positive feedback, negative feedback, or no feedback, and we get pretty reliably this kind of effect where the highest cortisol response follows negative feedback, but it's primarily because it doesn't recover as fast, not so much the peak. So positive feedback, still being socially evaluative, is enough to activate the HPA, but you have a faster recovery. And then control, really no activation of HPA. So the mother's sympathetic nervous system response is also differentiated. These kind of conditions are really sledgehammer kind of manipulations. You give somebody negative feedback, there's more sympathetic activation than if they get positive feedback, and of course, a little change being alone in a room and giving a speech. So all of this is fine. We've created these different conditions for the mother. Really the question here is what happens to the baby? The baby, again, comes back into the room. We're going to look at the changes in the baby's sympathetic nervous system responses within moments of being reunited with the mother. So this is that first 2 minutes of the baby coming back into the room. And what you see here is that the baby's physiology is differentiated in the same way that the mother's physiology is. Stronger sympathetic response for the babies whose mother got negative feedback, less so, a little bit more variance in this positive feedback, but the baby is more relaxed, less physiologically reactive if the mother was just in a room in the controlled, no stress condition. So to us, this is really exciting. And then our next step was to look at the extent to which, in that entire reunion period, how much did the mother and baby synchronize? How much did their physiological responses sort of co-vary and rise and fall in the same manner? And what you see here is a very strong effect over time. So this is the entire time that the mom and baby are together after the stressor. And if the mom got negative feedback, you see a strong effect for physiological co-variation. This is to the extent to which their sympathetic nervous systems are rising and falling. So don't just think up, they're more active. It's a correlation or a co-variation of their sympathetic responses. So up just means that they stayed linked. And what you see is with negative feedback, the moms and babies not only co-vary, over time they even stay more covariate. Much less of an effect, and actually even less covariate over time when the mother was in the control condition. Finally, from this study, we looked at the behavior of the baby to the evaluators who came in and offered a toy. What you see here is not so much a differentiation between the positive and negative feedback, but really any kind of social evaluation that the mother experienced resulted in the babies avoiding those evaluators. Now, these mothers had the same kind of exposure to the evaluators in terms of they were research assistants, they saw them, but these research assistants didn't evaluate them in the same way. And you see the babies much more likely to not take a toy and to avoid the evaluators for whom the mother was evaluated by. So that was the end of the first study. And in terms of what we think we saw in that first study, we saw that babies' physiological reactivity mirrored their mothers within moments of being reunited. The babies who received negative social evaluation showed the most physiological covariation, and this synchrony increased over the course of the experiment, and that babies showed social behavior consistent with the mother's experience, such that the babies whose mothers received social evaluation were more likely to avoid the evaluators. So lots of limitations to the study. We were very excited about it, but we knew, one, we wanted to replicate the findings, and two, we wanted and we knew, and we write about this in the discussion, we weren't sure how it was happening. We spent a lot of time looking at videotapes. What is the mother doing in those stress conditions that looks different than the control condition that the baby's picking up on? Was the mother's voice to sound more stressed? Was her facial expressions more anxious? What was happening that we could see? And it was very difficult. We had a hard time, and certainly our research assistants, when they were blind to condition, couldn't see major differences in terms of the mother's experience. But what we thought we were seeing, and what we decided to manipulate in the follow-up study, was how much the mothers were holding their baby or gripping. Remember, the baby comes right back, sits on the lap of the mother during the rest of the experiment. And so we were interested in going right after that mediator by manipulating touch. So in our follow-up study, we manipulate touch using almost exactly the same paradigm. So we did modify the positive stress condition. So instead of a high arousal positive stress condition, we created a low arousal, calm, positive affect that I'll show you in just a moment. So the design is the mother's experience, a stress task, same negative social evaluation, or calm task when she's separated from the baby. And then we manipulated whether when the baby was reunited with the mother, she sat right back on the lap like the first study, or the baby sat right next to the mother in a high chair. So now we've basically taken away the role of touch to see how much that can influence stress contagion. Again, we recruited almost 100 moms with their babies. None of the moms were in the first study, and ran almost the same study. A little bit different. Here's a timeline again. Mother comes in, does a baseline without the baby. Infant does a baseline with the mom on the mom's lap. We manipulate the maternal affect with stress or calm, and then the baby comes back in and sits right back on the lap, like I said, or in a high chair. We shortened the post-interaction, but still a reunion, a social interaction with the evaluators, and then some free play. So the low arousal positive manipulation was a videotape. And the idea was to create this feeling of social warmth in the mothers, and also to create a sense of calm. So I'm going to show you the videotape that we made.
She did to, oh why can't oh, someday I wish upon a star, wake up where the clouds are far behind. Be where trouble melts like a lemon drops, high above the chimney top, that's where find me, oh, star.
So you get the general idea, which is that we wanted to create, oops, oh, do I have to do, oh, sorry. So the idea was to create 10 minutes that had the mother in a relatively calm state. She's watching this video. The first half is sort of what you saw with these cute pictures of kids and moms and children to put her in a relatively socially engaged mood. And then the last 5 are these calm scenery pictures of landscapes and kind of spa music. The mothers loved it. Loved this manipulation. So she's very happy at the end of this. Here's the touch manipulation. This is what it looked like when the baby comes back into the room and either sits on the mom's lap on the right or on the top, and then in a high chair on the bottom. And this is in the reunion part where mothers and babies interact after being separated. So again, let's start with the moms. When you do these kind of sledgehammer manipulations, right, these aren't social, like subtle social manipulations like you'll find in my tribe when social psychologists do really good social psychology. These are huge manipulations, right? Having to give a speech in front of evaluators giving you negative feedback versus a calm, delightful video really creates huge differences in physiological responses, as you can see. On the left, we have the mom's sympathetic nervous system response, much higher in stress, not even active in the calm. And then you see her parasympathetic system. So we were able to increase her parasympathetic system with the calm video. And not surprisingly, with stress, your vagal brake withdrawals, and you don't get much resting or digesting from doing a socially evaluative task. But what happened with the babies? So one, were we able to replicate? I think we've all been there. Your paper already comes out and you're like, please let me replicate myself. And we did, thank goodness. When babies had mothers who were stressed, and we reunited the baby, put her right back on the lap, and within moments, that baby's physiology is higher than the babies whose mom was in the calm condition. But what about no touch? What if that baby doesn't go on the lap? It goes right next to the mother in a high chair. And the baby didn't react. In fact, if anything, there's quite a large decrease in sympathetic nervous system responses for the babies. I was showing this to a developmental psychologist, and she's like, the high chair companies will love this, right? You put them in a high chair, and all of a sudden they're calmer. So were we able to replicate the covariation finding? Again, here's stress and touch. Starts out low over the course of the experiment. There's greater covariation. If the mother was stressed and the baby's on their lap, you don't see any effect if the mother's stressed, but the baby's right next to her in the high chair. What about the baby's responses in terms of their parasympathetic system? Well, now what we see, a huge, worried me when I first saw it, because I think this looks too large. Double-checked all the scoring. This is the baby's physiological response when the mom was calm and they're in that high chair. You should interpret that large increase as a very relaxed baby. If heart rate variability is related to the sort of calm state. Less so, though, for the calm mothers with the baby on the lap. But importantly, with covariation on the parasympathetic system, and again, this is heart rate variability from the mom and the baby and how much it would rise and fall together. No effect for time, just a huge main effect for the entire experiment, where you see that the babies with calm moms showed higher physiological covariation of the parasympathetic system. So if I've imbued that with mental states, you have a calm mom and you have a calm baby, and they're having this synchronized physiological response. So we replicated the previous effect. Babies of stressed mothers showed increased sympathetic nervous system reactivity during reunion and more sympathetic covariation. When babies were placed next to the mother, though, in a high chair, stress contagion was not observed. So I don't think touch is the only mediator. I think it was a powerful one, at least in this case. Calm moms had babies who showed greater parasympathetic activity, especially in that no-touch condition, but across touch and no touch, there was greater parasympathetic covariation for babies who had the calm moms. So that was our first kind of foray into looking at affect contagion, again, among the closest dyadic pair we could think of. Does this happen with people who don't know each other? And if they don't know each other, what are the characteristics that come into play on who's more likely to pick up on the other person's affective experience? And I'm going to talk a little bit about social status as a catalytic property. So there were lots of, and I'll start just by saying that when I talk about social status, I'm using more the health psychology definition of social standing, which typically thinks of social status in terms of its socioeconomic features, education, income, occupational prestige. And there was enough clues in the literature that suggested that individuals with higher social standing would be more likely to be the physiological catalyst, or more likely to drive the affective tenor of the interaction. Adam Galinsky has lots of work showing that individuals in high power positions are simply less likely to engage in perspective taking. If I don't try to figure out what you're thinking, I'm not going to be mentalizing and pick up on your affective experiences. Low status and marginalized groups are also more likely to be vigilant, to remember features of their environment, and they're also more likely to mentalize. Keely Muscatel, a postdoc now at UCSF, showed really nice data showing that the neural circuitry involved in mentalizing is much more likely to occur for people low in SES than those high in SES. So we wanted to come up with a way to manipulate social status in the laboratory that wasn't based on someone's history, but that would be a powerful cue that somebody could just use as a cue of whether somebody is higher or lower in status. And I'm at UCSF, right near the Silicon Valley, and this was 4 years ago, and the iPads were really cool and brand new, and like we had our finger on the pulse of this great new thing, and we had this whole idea that we're going to hand iPads to our subjects versus a laptop, and if I'm holding an iPad, you're going to imbue me with all sorts of social status, and that's going to be powerful. And then right when we were ready to start the study, I had just had this horrifying moment where I thought, when this paper finally comes out, they're going to be giving out iPads at McDonald's, and we're going to look like idiots. And the paper that I'm about to show you just came out like a week ago. And the day it came out, I Googled how many iPads exist. They've sold 237 million iPads. So I'm glad that I switched. And I think it tells the grad students, try to study something timeless so you don't look ridiculous. So you probably saw what we manipulated is what our subjects were wearing. Our subjects, these are all male subjects. They came to the lab, and we told them that in addition to measuring their physiological responses, we had some ambulatory devices that were embedded in clothes, and we just wanted them to wear those ambulatory devices, and we placed the clothes out in the subject room, and we said, could you just put them on? So we didn't highlight that the clothes were either really crappy sweats from Walgreens with like plastic shoes, but everything's clean in both conditions. But they put on these, and there's all these like sensors sewn into it, but they're all fake. And there was an iTouch phone, but it all looked very real. And they put either the sweats on or a suit. We had 9 different suits, all different sizes, but they're all exactly the same, freshly laundered shirt. And we picked out the right size and 6 pairs of shoes, all different sizes. Talk about a miserable study to run. But it was powerful in terms of being able to put on this symbol that presumably told, or conveyed information about status. So here's how the study goes. We recruited 128 male participants between the ages of 18 and 34 to create 64 dyads. We confirmed they didn't know each other prior, so these are all strangers. We did lots of matching in our recruitment, so we try to match dyads based on race, and we always did same race and ethnicity, similar occupations. So UCSF doesn't have undergraduates, so I don't have student samples. But if I had a student, I would recruit another student. If we had somebody who was like a manager, they would be paired with another manager. So really some complicated ways to sort of create at least similar kinds of dyads. And we also had a rule about similar age. They had to be within 4 years of each other. So these are relatively similar kinds of male dyads interacting with each other. The actor was just randomly assigned that they had to show up 15 minutes early, and they're the ones who we said, in addition, part of the study is that we're going to be trying out these ambulatory measures. Here are your clothes that we want you to change into. And then they saw the high status suit, the low status sweats, or in the control condition, we said the same thing. Oh, ambulatory stuff isn't working. You don't need to change. Our hope was to reduce the demand characteristics of status. The partner arrives, they don't know anything about this. They just see their partner wearing the suits or the sweats, or their clothes, and they met each other and participated in the study together. So they do separate baselines where they don't know each other yet. The actor changes, they meet, the diet goes into the same room, and they have a face-to-face social encounter. First, they kind of get to know each other, they share some background information, and then they have to do a negotiation task. This negotiation task provides separate information to the actor and the partner. One is selling a piece of real estate, the other person is buying a piece of real estate. It's a task that's used pretty often in the organizational behavior world. And then we look at how their negotiation goes. Who conceded, who was more likely to sell the real estate at a lower price than the person who they're negotiating with. Primary outcome variables are the testosterone changes, so we're measuring baseline testosterone and then change in testosterone as a result of the interaction, negotiation behavior, and of course, for the purposes of this talk, their affect contagion, who was more likely to drive the other person's physiological responses. So let's first just look at negotiation behavior. Here is the actor's manipulation. So if the actor put on sweats, they were more likely to concede. They were bad negotiators. They were more likely to sell or buy, because that was all counterbalanced, sell or buy the plant for less money. So don't wear sweats when you are negotiating the price of your home, whether you are buying or selling, because they conceded more money in the sweats than the other conditions. And when your partner is wearing sweats, so this is a partner effect, your partner is wearing sweats, the males had a higher testosterone increase than when your partner is wearing a suit. But for the purposes here, what we were most excited about was looking at physiological linkage. Same physiological measures on the table, the pre-ejection period, that sympathetic nervous system response. If I use person A's responses at time 1, does that predict partner B's responses at time 1 plus 1? And we first ran the model with the actor predicting the partner and then switched the model, first looking at low status, and we see no effect either way. So wearing sweats had no influence on this partner, and we didn't see a partner effect affecting the actor. What about high status clothing? Here, when the participant was wearing the high status clothes, they were more likely to influence their partner's physiological responses. So whether he's activated or calm predicts his change in physiological responses in a 20-second time bin later. And when we reverse the model, there's no effect. So in this case, social status did work to trigger that catalytic affect contagion, and we don't see that happening with lower status individuals. So my final series of studies is going to take me back to my roots, which is, as Tony said, with interracial dyads. And I'm going to do something a bit atypical, which is I'm going to tell you the results of the study and then work you backwards on how we got there. So with dyads who are from different race groups, and I almost always study whites and African Americans, European Americans and African Americans, sometimes Latino Americans, but the largest effects are when, with interracial anxiety at least, or with European Americans and African Americans, and in general, they don't show physiological covariation. Put two people in a room who are same sex, but different social groups, different race groups, have them do a cooperative task, not even something competitive, and their physiology doesn't synchronize. You put two people of the same race in the room doing the same task, and they do synchronize. Now, this is interesting, and there are lots of reasons and clues in the literature on why this would be the case. So we wanted to design a study where we created physiological synchrony among two people who were from two different racial categories. And our clues, and from the work that we had been doing, both European Americans and African Americans approach interracial interactions with more meta-monitoring. They just spend more cognitive work than they do when they approach a same-race interaction. And we reasoned that this meta-monitoring interferes with the authenticity of the interaction. And it derails that ability to pick up accurately on the physiological responses of your partner or the affective responses of your partner. Furthermore, we had other data that we published that showed that there was a strong in-group advantage. So if I'm judging other European Americans, I'm pretty good at detecting the emotions, the stress, the anxiety that they feel. But when I'm looking at an African American, I'm not only bad, I can be significantly wrong. We can predict it the wrong way. I think they're stressed, but they're calm. I think they're calm and they're stressed. So in that final study that I'm going to get to in just in about 5 minutes is that we took dyads, and before they met each other, dyads from different race groups or same race groups, and before they met each other, we cognitively depleted them. We tried to make it impossible for them to engage in these meta-monitoring strategies that we thought were derailing the social interaction. So we deplete them before they meet each other, and then we have a control condition, and then we look at their physiological synchrony. How did we get to that prediction? Well, as Tony mentioned when she introduced me, for years we've been studying this idea of intergroup anxiety or intergroup threat, and lots of other people have studied this, but in general, majority group members, and this is almost exclusively European Americans, tend to show more negative affect, threat, anxiety, and fear during these social interactions with minority group individuals. And this occurs at the physiological level or neural level, everything from increased blood pressure, less efficiency of their cardiac cycle, more tightening of their vasculature, lots of physiological evidence that whites are experiencing more threat and anxiety when they're interacting with African Americans. But the emotional reports, the subjective reports, would often show a very different finding. Specifically, self-report ratings of whites of their African American partners are often much more positive than whites' ratings of other white partners. So they'll not just imbue them with more positive traits, they'll also report being happier, they'll smile and laugh more with out-group partners than in-group partners. So I'll give you a quick example. We brought in about 100 subjects and made them do a true social stress task, and all we manipulated is whether the evaluators were 2 whites or 2 African Americans, and these are all white subjects in this case, and we measured their neuroendocrine responses and also their implicit racial bias. And what you see here is that the higher our white subjects were in implicit racial bias, the lower their dehydroepiandrosterone. Dehydroepiandrosterone is an adrenal steroid. It counteracts cortisol. You have lots of it when you're young. As you age, you lose it. High levels are good. And it responds to the same secretagogue as cortisol, but it helps shut it off. So high levels are good here. And what you see is higher implicit racial bias is associated with less of this good stuff, only when you're evaluated by outgroup members and you're higher in racial bias. When we looked at these same videotapes, we also saw this large main effect across several studies, where when whites are evaluated by white evaluators compared to black evaluators, they show more positive emotions. And here's a great example. One of our largest effects is always they smile more with out-group members than in-group members. And so you should be asking, are these people who are smiling and laughing more, are they the ones who are the most threatened? And they are. When you look at the whites whose cardiovascular responses indicate more of a threat pattern, what you see is the more threat is associated with more positive behavior directed at their black partner. In short, it looks like whites tend to overcorrect, and that overcorrection seems to stem a little from intergroup anxiety and also from probably some racial prejudice. But there does tend to be just an overall main effect of overcorrecting in general. Now let's switch over to the minority group member. What does a minority group member do in a social interaction with a white? Well, there's lots of good theory by Brenda Major and Jenny Crocker that for minority group members, they go about their social interactions with an extra attributional explanation. And this theory has most often been cited to explain why African Americans, for example, might have higher self-esteem even though they live in a society that potentially discriminates against them. They also might respond to negative feedback with less of a reaction than if they got that negative feedback from an in-group member. Less sort of underscored in this line of research, though, is a very interesting finding about the downside of attributional ambiguity with regard to receiving positive feedback. So in general, what we see across a number of studies, when African Americans get positive feedback from whites or outgroup members, they're more likely to discount it. They'll question the authenticity. They see it as maybe whites' clumsy attempt to not be prejudiced. And when you combine that with what I just told you about overcorrection, we sort of have these two trains running against each other that are problematic. And they're on that same rail of whites overcorrecting, trying not to look prejudiced, African Americans questioning the motives of that positive behavior. So let me give you just one of my favorite examples. We went into the homes of some African Americans, and we had them do this online chatting program where they thought they were chatting with two other whites or two other African Americans. And the chatting program is actually our research assistant just following a script. And he's giving everybody positive feedback during this chatting program. We're taking screenshots of their faces. Here's when African Americans get positive feedback from two in-group members. They're very happy, laughing. Here is the same positive feedback from out-group members. So you should never believe pictures because they're cherry-picked. What does the data say? Same kind of effect. So in a paper that we published in 2008, similar design that we ran in the laboratory. This is performance on a cooperative task. These are Confederates who gave either positive or negative feedback that they're blind to condition because it's written, and participants who are white and black. You perform well after positive feedback in every condition, but black subjects who got positive feedback from white partners. That undermined performance. Why? Because you're hypervigilant. We then did behavioral coding, looking at the extent to which the black or all the subjects monitored their social environment. Positive feedback made them monitor more, meaning they took their attention away from the cooperative task and scanned their partner, presumably looking for clues and cues of was this genuine feedback. Finally, when you look at the physiological responses, all you really need to know, this is how efficient their heart is beating, and this is the amount of constriction versus dilation in the arterioles, which is getting blood out to the effector muscles. And again, the black participants with white partners who gave them positive feedback, less efficient heart, more vasoconstriction leads to higher blood pressure. So the sum of this is that for African Americans, getting that positive feedback was threatening. So again, whites and African Americans possibly enter interracial social interactions with not just different motives, but motives that inspire or engage more meta-monitoring. So our thinking was, if we can prevent them from engaging in this overcorrection or hypervigilance, would the dyad then synchronize because there's a more genuine or authentic affective reaction. So my final study, we brought in this case, 246 participants, 165 whites, 81 blacks, which created 123 dyads, 81 cross-race, 42 same race, but you should know all same race were white-white. So I don't have a black-black condition here. We matched the dyads on sex, student status or not, and age, in this one within 2 years of each other. And here's the only thing we manipulated. I mean, other than the racial makeup of the team, we manipulated whether, right before they met each other, we depleted their cognitive resources by having them count down from a 5-digit number by steps of 7 for 5 minutes to a metronome. It's very hard to do. There's an experimenter right there, faster, 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 and it's not fun and it's not easy. And the idea was to just cognitively deplete them. The control condition had them count up from this number by steps of 1, which is of course very easy. Here's just a quick timeline. They do an online session. One of the things that we collect is the race rejection sensitivity. So this is for African Americans. We ask, to what extent do you expect or are anxious about being rejected from whites? They arrive to the study. They don't meet each other. We consent them. We apply the sensors. They do a baseline. And then we deplete them or not. And these are always yoked. So if partner A gets depleted, so does partner B. We move them into the same room, and now they do cooperative tasks together, and I'll tell you about one of them. And then we separate them to do a social trust game. So one of my favorite tasks that we developed is this, what we call the touch task. We have our subjects put their hands into a box, and one of them signs out a word. Okay, so Katrina is looking at a word here. That word is cat. And then there's an American Sign Language placard that tells you how to spell C-A-T. She puts her hand in there, and she makes these symbols with her hand. The goal is for her partner to feel around her hand to figure out what letter she's making. Why would we do this? Well, because they're both wearing impedance cardiography, and it uses an external current, when two people touch who have an external current, you get noise. So perfectly down to the millisecond, we know how long they were touching. So their hands are in a black box. They think nobody knows how long they're touching, and we can precisely get to the millisecond. This is how long they touch. And people differ wildly in how much they touch. So we've used this task for people who know each other, spouses, parents and children, strangers. Men touch less than women, especially male strangers, like they barely touch and they keep pulling back, which is really funny. 2 extroverts touch more than 2 introverts. Spouses almost never let go of their hands, which is really cute. So do mothers and children. They'll just almost touch continuously. Fathers let go of their hands more. So we really love this task to tell us very implicitly and very subtly about the comfort for which people have during these social interactions. And then finally, a trust task. I'll just tell you about the results real quickly. At the very end, they both earn a bonus, a monetary bonus, and they have to decide how much they want to put in this joint pot that then will get multiplied by 1.5 and split it. We give them the payouts, which basically say, you know, if your partner screws you and you don't, this is how much you'll make, and all the different possible permutations, so they know exactly what they're going to do and what they're going to get if they contribute X amount, and then of course have to imagine what their partner is going to give. So here are just some screenshots of our fun subjects. It was really easy to find mimicry in this study. I don't know why it's all women. It wasn't all women, but those are the pictures. Okay, so first the manipulation check. Can this, does this depletion manipulation really deplete people? Yes, people who had to do that backward counting reported being more mentally tired by the end of the experiment and right afterwards than those in the control condition. Here are some results from the touch task. These are African Americans, rejection sensitivity. So the more rejection sensitive they were, the less they touched their white partner in the control condition. But if we depleted them, if they were both exhausted, the African American was touching the hand of their partner more. And finally, what I already told you from the beginning, 2 people from the same racial group, in this case just 2 whites, show physiological covariation. Their physiological responses rise and fall similarly. And that didn't matter based on depletion or control. The 2 whites showed strong covariation. For an African American and a white dyad, we don't see physiological covariation in the control condition. This replicated other studies that we had seen. But for us, that's the exciting line. When you deplete both of them, and presumably they can't engage in this meta-monitoring, you create more physiological covariation. Why would we want more physiological covariation? Because covariation is related to something like, in this case, mutual trust. So they were more likely to trust people the higher that covariation. So I'm going to end here by just telling you this. What can people do with this kind of work? I'm in a medical school, as Tony mentioned. And so I sort of have access to lots of interesting groups, and the group emotional tenor matters. So for a couple years, starting at Children's Hospital in Boston and now at UCSF, we've been going into surgical teams and applying this life shirt under the scrubs of the people on the surgical team and looking at the physiological covariation of that group with the intent to eventually apply it to surgical outcomes. But right now, we've just been looking at how status plays out. So the person, whoever's holding that scalpel, tends to predict the physiological responses of the others on the surgical team. But if you take somebody like a scrub nurse or an anesthesiologist and use their physiology to predict the others, you get no effect. So basically, again, status plays out in a really powerful way. And of course, what's fascinating about this is how little you see of the face because of the masks. From what we can tell, a lot of affect is communicated in the voice. So here are the questions that keep me up at night. I argued all this from an affect contagion. I don't really know if it's arousal contagion. I sometimes wake up in a cold sweat that I would find these same effects if somebody just exercised, because it's just something that's arousing that would be communicated. I don't think so, but would an exercise or sympathetic agonist engender the same kinds of effects? Negative emotions seem to be caught much easier and faster than positive emotions. People have been disappointed and wanted us to find, positive emotions, spreading. That's been really hard for us. We've had lots of failure of studies of trying to get physiological covariation or affect contagion of positive emotions. Maybe we haven't done it right yet. And then how influential are the various sensorial components. I think odor is fascinating. I didn't know anything about it, so we got afraid and didn't want to do the odor manipulations, but I think there's some really interesting base sensorial components that one could manipulate as possible mediators. And with that, I thank all the great people that were part of these studies that I talked about, especially Tessa West, who does all the mathematical modeling and is just brilliant, and I thank all of you for your time.